They took a UH-60, removed the pilots, and turned the cockpit into cargo space you can load with rotors turning. That's not science fiction. It's Sikorsky's U-Hawk prototype. We'll map the new front end, clamshell doors, ramp geometry, and the cabin volume increase that makes a 24 to 50 launched effects quiver feasible. Then we'll show how adjustable autonomy via matrix shifts from civil routing discipline to combat ingress, and why a centerline HIMARS pod or JMIC stack is now a realistic trade. Before we move on, please take a moment to subscribe to the channel and like the video. If the pilots are gone, what holds the nose together when you cut out the cockpit and start loading cargo under a spinning rotor system? The baseline UH-60 nose is a compact triad. 2 crew stations with crash-worthy seats on deformable mounts, a glazed shell that feeds visibility but also carries shear, and an avionics bay and battery compartment set into the lower nose around the keel beam. Those parts aren't just habitability, they complete structural loops. The windscreen posts act like short columns, and the instrument panel bulkhead closes a torsion box with the cabin frames. Remove pilots and glazing, and you don't just gain volume. You also remove load paths for bending and torque. The U-Hawk problem is to open that volume while keeping continuity to the mast, engine inlets, and landing gear frames. The risk is straightforward. Take out bulkheads, and the nose can washcloth twist under rotor torque. Change the fairing shape, and you can disturb inlet pressure recovery and feed unsteady flow into the main rotor disc. So the redesign steps in where the crew bay used to stitch things together. The cockpit gives way to clamshell doors and a forward ramp. Each door runs on a hinge line tied into new ring frames, with latch arrays spaced like rivet rows across a spar cap. When the doors close, those latches clamp skins to frames and recreate a stiff hoop, so the nose regains shear strength the way a jar regains rigidity when its lid is on. The ramp folds up to form a bulkhead plane, and its locks seat into reinforced receivers that bridge to the keel beam, turning a moving panel into a structural member when closed. Floor structure does the heavy lifting. The forward deck gains doubler plates and longitudinal load spreader rails that extend into the former nose. Pallets and UGV axles ride those rails so load enters through multiple fastener lines instead of punching the deck at a point. You can think of it as swapping a single jack for cribbing. Lower peak stress, same total force. Rollers or low-friction strips sit inboard to ease forward movement, and chocks index common axle spacing. So the forward center of mass doesn't shift unpredictably in a brake tap or gust. Crash loads and rotor dynamics force conservative choices. Key cabin frames near the mast step stay, and new ring frames close the nose perimeter where glazing once carried load. Added longerons run from the ramp frame to the original nose gear mount region and tie directly into the keel beam. Shear ties connect those longerons to existing cabin frames so torsion finds multiple paths aft. That stack-up keeps mast plane alignment tight under dynamic loads and preserves stiffness so control laws don't chase flex. They claim a 25% internal space increase. If you sum that into the UH-60 cabin, you get enough forward volume to stage 2 JMICs ahead of the original cabin station, while still leaving aft space for additional cargo, or to stack a 24 to 50 launched effects quiver where the crew once sat. The number isn't an abstraction. It's the difference between a single-row load and a staggered 2-row load with safe aisle clearance. Rotor turning load-in drives geometry. The door arc has to clear ground personnel and pallet corners, so hinge axes sit high and slightly aft to swing the blades outward and away from the ramp line. Ramp angle stays shallow, so casters don't scrub, and UGVs maintain traction, and ground clearance under the nose prevents strike when the gear compresses. A tablet-driven precision mode slows control response and holds attitude like a crane, trimming drift near the mast plane while load teams place mass within centimeters of the planned tie-down grid. Structural integrity is maintained by redistribution. New frames, reinforced floor and door and ramp locks that act as temporary frames when closed rebuild the torsion box without pilots and glass. With the front end now a loading machine, we can move on from space to what you actually move. Weights, containers, and launched effects. How does one airframe pivot from resupply to counter UAS to precision fires by rearranging a few modules and a tablet plan? The payload math is blunt. Internal payload, 7,000 pounds. External, 9,000 pounds on the hook. The modular catalog spans launched effects quivers in the cabin, joint modular intermodal container stacks, roll-on, roll-off unmanned ground vehicles, and a centerline precision fires option built around either a single HIMARS pod or 2 naval strike missiles and canisters. It was therefore designed to swap roles without rewiring the aircraft, and to do so quickly. Weight is not the only limiter. Center of gravity moves as you load forward versus aft, and drag rises sharply with external canisters, so range and climb rate shift in ways that matter to route planning. Egress profile sets whether you can come off the landing point safely with a forward CG, or whether you need to stage a lighter external first. Put effects inside and you protect them from weather and radar, but you pay in cabin volume. Hang them outside and you pay in drag and signature. The launched effects quiver follows a simple rule. Short and medium-range rounds live inside the cabin where you can pack them densely and service them under cover. Long-range or larger diameter rounds sit on stubs or wingtips to clear plume and sensors. Mixed racks let you fly ISR and electronic warfare alongside decoys and loitering munitions in the same sortie, so you can blind, spoof, and then strike without changing airframes. Capacity scales with the package. 24 to 50 launched effects fit depending on diameter and fin planform. If you combine internal and external cargo, up to 4 JMICs come into play, with 2 staged forward and 2 held either aft or slung. Tie-down rings run in a grid so you can cross-strap independent of pallet size, and roller paths protect the floor by spreading point loads into multiple frames. Under maneuver, that network resists creep and keeps the CG inside the control envelope. UGV deployment works forward through the new ramp. Axle spacing dictates how far you can roll into the former nose volume before a tie-down, and chocks match common track widths, so you don't chase wheels during a brake test. Metrix's precision ground mode dials down response rates, holds attitude, and allows centimeter-level placement, so a small robot can be set on the ground without a bounce or a swing under the rotor disc. Expeditionary fires add a different calculus. A single HIMARS pod on the center line concentrates mass and keeps symmetry, but it induces drag and needs a reinforced keel pickup with shear webs to take the vertical and torsional loads. 2 NSMS in canisters divide weight laterally and increase form drag, so range falls, and you need stricter CG margins to preserve tail clearance during flare. Both options rely on structural hardpoints that tie into the keel and cabin frames and accept transient recoil loads and gust response without twisting the nose. By way of an operational vignette, a troop ahead ingress can open with a salvo of launched effects to blind local sensors and inject spoofers, followed by a low hover and a UGV spill to extend eyes down a street network or into a tree line. Cargo moves off in sequence while the aircraft stays unoccupied, and it departs before humans step out from cover, which reduces exposure to small arms and first-look air defenses. All of this stands on specific changes. A reinforced floor and tie-down lattice that carries 7,000 pounds without local buckling. Redistributed structure forward so the nose remains stiff while loaded. A hard-pointed centerline for pods or canisters. And autonomy modes that hold the airframe steady as mass shifts on or off. With payload sorted, control logic is the last gate. How Matrix toggles from civil routing discipline to combat ingress and lets minimally trained operators task a complex loadout. The leap is structural as much as it is algorithmic. By this point, the airframe behaves like a kit. Frames, rails, and hardpoints create a flexible effects carrier and an unmanned loader that keeps its torsion box intact while swapping roles in minutes. If you want to follow up on Matrix's adjustable autonomy, civil routing versus combat ingress, say so, and we'll dissect mission software, operator workflow, and a tablet-driven simulation of launched effects sequencing and cargo planning. One way or another, the question isn't whether a Black Hawk can fly uncrewed. It was therefore about tempo. How fast Doctrine and training absorb that modular capacity and employ it.
Signals